Welcome to today's lesson on Grade 9 Mathematics. Today we will be going through the memo for the Exponents2 worksheet, which means the second worksheet on exponents that you did. Let's get started. So the first question on the Exponents2 worksheet reads, 4x cubed times 2x cubed. We can see that the variable in both of these is the same. They both have an x, which means we can simply multiply these numbers together. So 4 times 2 is 8. Then they have a common x, and when you multiply exponents, you add them. So we have 3 plus 3, and you're left with 8x to the power of 6. B reads x to the power of 5 times x to the power of 3. So the same thing, we have the same variable, which means we can add our exponents. X to the power of 5 plus 3 equals x to the power of 8. Question C, same thing, we both have an x as our variable, but we have coefficients of that, which means we need to multiply them. So 2 times 2 is 4, and then we have x to the power of 3 plus 2 equals 4x to the power of 5. D reads negative 9x to the power of 0. The rule is that we have to do what's in the brackets first. So we leave the negative. Anything to the power of 0 is 1, and you're left with negative 1. Always remember to keep the negative if it's outside the brackets. Question E reads y to the power of 4 all raised to the power of 3. So when we're using brackets and we're raising something to a power, we use the quotient rule. We're going to have to multiply our exponents. So we are left with y to the power of 4 times 3, which is y to the power of 12. If we have a fraction, which means we're going to have to get rid of our denominator, whenever you take an exponent from the denominator and move it into the numerator, the sign of that exponent changes. So we can divide 6 by 2, and we're left with 3. We have both of our variables are x, and then we have x to the power of 7 minus 4. And the minus 4 because this 4 over here, when you bring it up to the numerator, becomes a negative 4. So we're left with 3x to the power of 3. Question 1G, we have two brackets that are both raised to a power, which means we need to clear that power first before we can multiply our brackets together. So let's start off with 2 to the power of 2, which is 2 squared, is 4. C to the power of 1 times 2, because when we raise a power or we raise an exponent to a power, we multiply them. So c to the power of 1 times 2 is 2, and d to the power of 4 times 2 is 8. Times, because this brackets mean that they are times together, times c to the power of 1 times 5 is c to the power of 5, and d to the power of 1 times 5 is d to the power of 5. So now when we multiply exponents, we add them. So we can say 4c to the power of 2 plus 5, d to the power of 8 plus 5, because we're adding these exponents. And you're left with 4c to the power of 7, d to the power of 13. Question H is similar, where we have two brackets, both raised to the power. So let's get rid of the powers first. 2 to the power of 3 is 2 cubed, which is 8. F to the power of 4 times 3 is f to the power of 12. And then g to the power of 1 times 3 is g to the power of 3. Times 3 to the power of 2 is 9. And then f to the power of 1 times 2 is f squared. And g to the power of 5 times 2 is g to the power of 10. Now we're going to have to multiply the 8 times the 9, and you're left with 72. Now when we multiply exponents, we add them. So we have 72f to the power of 12 plus 2, and g to the power of 3 plus 10, which is 72 f to the power of 14 g to the power of 13. Question 1i, we have a fraction that's raised to a power, which means let's do what's inside the bracket first before we raise it to the power. So what I mean by that is let's get rid of the denominator. And what we do when we get rid of the denominator is we move our exponents to the numerator. And when we do that, then the sign of the exponent changes. So we can say 5 divided by 20 is 1 over 4. X to the power of 3. And then we have an x at the bottom here. So when we move that up, it becomes minus 1. Then we have y to the power of 1. And we have this 5 that we need to bring up. So that becomes minus 5. And this is all still raised to the power of 4. So we end up with 1 over 4, x to the 2, y to the minus 4. Now we can take that power away, and when we multiply exponents to when we take an exponent and we raise it to another power, we multiply them. So 1/4 raised to the power of 4 is 1 over 256. You can use your calculator to work that out. Then we have x to the power 2 times 4 is 8. And y to the power negative 4 times 4 gives you negative 16. But this is not the final way we can write this. We can simplify it further and say we leave all our positive exponents on the top, and our negative exponents, we can move them to the denominator. So we can say x to the power of 8 all over 256 y to the 16. And that is just saying that 1 over 256, that's why this 256 is in the denominator. Looking at question J, we have something in front of the bracket, but the bracket is not raised to a power, which means we can multiply into our bracket. When we multiply exponents, we add them. So 5 times 2 is 10. X to the power of 2 here plus 4. And then y to the power of 1 minus 3 gives you 10x to the 6, y to the minus 2. But this, we can say it's 1 over y squared. It's the same thing. So let's write this as a fraction. So we have 10x to the 6 all over y squared. That's just being able to write it in a more simplified way. Moving on to question 2. We have an entire fraction raised to a power, which means we can do what's inside the bracket first before we raise it to a power. So when we move exponents from the denominator into the numerator, the sign changes. So we can say minus 7 divided by 3 is minus 7 over 3. It doesn't divide nicely, so you can leave it as a fraction. It's not a whole number. A to the power of 2 minus 2, because we're taking this 2 up. B to the power of 3 minus 3. And then C to the power of 0 minus 7. All still raised to the negative 4. So let's simplify this. Minus 7 over 3. A to the power of minus 2 minus 2 is A to the 0. Same thing will be B to the 0 because 3 minus 3 is 0. And then C to the negative 7. All raised to minus 4. We know that anything to the power of 0 is 1. So we can write minus 7 over 3 c to the minus 7 all to the power of negative 4. And that's because our a to the power of 0 and b to the power of 0 is just 1. So let's now take our power and put it into the bracket. When you raise an exponent to a power, you multiply the exponents. So minus 7 over 3 times a negative 4 gives you 81 all over 2,401. You can use your calculator to work that out. Then we have a minus 7 times a minus 4 gives you a positive c to the power of 28. That's your final answer. B, we have the same thing where we have a fraction with exponents inside a bracket that's raised to a power. So let's do what's inside the bracket first. Minus 2 over 3, leave it as minus 2 over 3 because once again, it's not a whole number, so we'll be left with a decimal. Simpler to leave it in the fraction form. A to the power of 3 minus 3 because we're bringing this 3 up. And then b to the power of 2 minus 4 and c to the power of 0 minus 3, all raised to the power of negative 2. We have minus 2 over 3 in the brackets, a to the power of 0 because 3 minus 3 is 0, b to the power of minus 2 because 2 minus 4 is minus 2, and c to the power of minus 3, all raised to the power of negative 2. So now we can then take our power, our exponent here, and put it inside the bracket. And when we multiply, when we take exponents and we raise them to a power, we multiply them. So negative 2 times, or rather, minus 2 over 3 raised to the power of negative 2 gives you 9 over 4. A to the power of 0 is 1, so we can leave that. B to the power of negative 2 times negative 2 gives you b to the power of 4. And c to the power of minus 3 times minus 2 gives you c to the power of 6. And that's also your final answer.